Okay, so let's start with how a printed circuit board is actually made up. So as you all know, we've had a look at a circuit board. We've got one just here, which is, I believe, a single-sided. So that would be classed as a single-layer PCB. And the reason being is there's one copper layer on the back, and that's it. So typically, we would call this a PCB stack. And what normally happens is we have an insulator material in the middle of the stack. That's normally FR4, some kind of fiberglass or something like that, depending on the type of circuit you're working on, but usually it's a fiberglass material that's an insulator. And then on top of that, we will have, for a single layer board, a layer of copper. And then if it's a double layer board, so we can solder on both sides, we'll have another layer of copper at the bottom, glued onto it, if you like. And what we have here then is this is our insulator. Here we have our top layer, and here we have our bottom layer. Yeah? On top of that, we then have, which I'll use a different colour for, a silk screen. And a silk screen, or it's a solder resist actually, we have a solder resist. And what that is that's the green coloured material that you see on top of the PCB. And the reason for that is when you put a footprint on a PCB, you might solder a device with many, many legs. And the distance between these legs, the pitch between the pins, very, very small. And so when you solder it, your solder melts across and bridges the pins together. Disaster. Spend hours trying to fix it. If we put a solder resist chemical over the top of it, it actually fills in these gaps between the pins and it stops the solder from flowing. So it makes life a lot easier to solder. And not only that, is it puts a protective coating on top of the copper, which means it doesn't oxidize, so it doesn't disappear with age. Yeah? It doesn't become corrosive. Now on the top of the solder resist, so we have a top solder resist and a bottom solder resist. On top of that we have a silk screen. And that is where we can print our text. So for a double layer board we have the following stack. We have an insulating layer, we have 2 copper layers, 2 solder resist layers and 2 silk screen layers. Yeah? And each one of those layers is represented in the software as an individually selectable layer. And you have to choose the right layer to apply the geometry that you want to apply when you build your PCB. So if I'm drawing tracks, I'm obviously drawing them on the copper layers because the copper represents the wire that I want to use to connect the components. If I'm then deciding I want to put some print on there, I have to select the silkscreen layer and I put my text on here. If I don't get that right, if I've selected the copper layer and I put some text, the fab company, they won't not do it, they will actually etch in copper the text you want and then put the solder resist over the top. So it's up to you to get it right. Yeah? And as well, if you put some text on the top layer and then decide, no, I want that on the bottom layer, then when you put it on, actually what happens is it goes in the machine, it flips it around, so your text will be mirrored. It will actually be the wrong way around. You need to mirror it in the software so that when it's produced, it comes out in the correct orientation. Make sense? So, when we talk, any questions about the PCB stacker? You can obviously have 4 layer, 8 layer, 12 layer, yeah, and all that happens in that case is you'll have another insulating layer between the copper layers. So you'll have an insulator, a copper, an insulator, a copper, however layers you want, and then your solder resist will only be at the top of the bottom and your silk screen will only be at the top of the bottom. So, if we have a 2-layer board and we have copper here and we have copper here and I have a through-hole component, yeah, then obviously I need to drill all the way through the layers, yeah, so that I can have my component, let's say it's a standard resistor, looks like this, and I come along and solder it on this copper layer here and on this copper layer here. Because what happens with the solder resist is it gets pulled back to release a bit of copper so you can solder on it. Yeah? So for a through-hole component, I'll go all the way through. If I have a wire, and I want the wire to connect through there, then same thing again. I'll drill all the way through, I'll solder it on the bottom copper. But there's also a via, or via, however you want to call it, that you can put in your software. So if you need to connect a trace on the top to a trace on the bottom, it can happen automatically. And what they'll do is when they fab the PCB, they'll drill the hole for you, and they'll put a piece of tin inside there that links those two positions, yeah? So you can apply that on your PCB if you want. If you have multiple layers, let's say we have 4 layers, so we have a copper layer, an insulator, another copper layer, another insulator, and then another copper layer, like this. You can have different kinds of vias. You can have a full via that starts from here and ends here and connects every copper along the way. You can have a blind via that starts here and ends at another copper layer. Yeah? Or you can have a buried via that links a copper layer inside to another copper layer inside but never exposes on the outside. So 3 types of via, and it's down to your production plant as to whether they have a capability of doing that for you. Yeah? Okay, so if we then look, we all know that a through-hole component will look something along these lines, and we'll have these 2 pins that will go through the board and we'll solder to them. Yeah? So if we have a surface mount component, looking top down, so I'm looking at the surface mount component, let's say it's a resistor, you'll just have 2 exposed metal pads either side. And that will sit on the copper track. So the copper pads will be a little bit bigger, like this. And then your solder will flow around here and here, yeah? And so it will just literally sit on the top and you'll attach it with some solder. Now, there are multiple sizes of these surface mount components.